All right, guys. Today we're going to talk a little bit about another form of energy that we happen to have, and this is what's called kinetic energy. Kinetic energy is the energy of motion. So anything that is moving can have kinetic energy. Now, kinetic energy really just depends on two things. It depends on the mass of the object. What is the overall size? Is it pretty small? Is it pretty large? It's the difference between stepping in front of a tennis ball that might be rolling down not very fast versus there's a bowling ball coming at you. One's going to hurt a little bit more than what another one will. The other factor that kinetic energy depends on is the velocity of the object. How fast is it moving? If it's not moving, it has no kinetic energy. Things have to be moving in order to have this type of energy. Now, what exactly is our equation? The equation for kinetic energy is Ke, that's just one thing. The kinetic energy is equal to 1/2 divided by or multiplied by m times v squared. Ke is 1/2 mv squared. You might also see me write this down as 0.5 times mv squared because the 0.5 just ends up being the 1 divided by 2. Now, a couple things with this equation. With the equation for GPE, this equation that you used the other day, honestly, it did not really matter if you had the order messed up. If you said the mass and height were opposites, where m is 60, h is 2,500, when you plugged into this equation, it wouldn't have mattered. The order of multiplication doesn't matter because you're just taking those three values and multiplying them together. However, with kinetic energy, because only the velocity gets squared, we have to make sure that we're very careful. It's not squaring the entire thing. It's only one variable that gets squared by itself. So as I take a look here at the first example, I have a 2,500 kilogram roller coaster car that's traveling at a speed of 28 meters per second. The 2,500 kilograms, that measures my mass. That's 2,500 kg. The V, which is speed. Speed or velocity can use pretty much interchangeably with this, but I'm going to take the 28, that is my V, and when I plug in to 1/2 mv squared, 1/2 is just 0.5, the m is 2,500, and the velocity is 28, only this term gets squared, and what I end up with is 980,000 joules. We will end up getting some big numbers with these potentially. Anytime we're talking about big objects that are moving pretty fast, there's a lot of energy associated with those. And just abbreviated here at the end, we have all energy gets measured in joules, regardless if it's in gravitational, if it happens to be in kinetic, all of those are the same energies. Again, if you're using the calculator app in Google, if I'm typing this in, 1/2 or just 0.5, multiplied by the mass, 2,500, multiplied by the, how fast was it moving? 28, 2, 8, and then if I'm looking for the square button, well, stupid buttons. All right, here is the exponent. Nope. Where's the back button? There, squared. So I got to press this button, then I got to press the square. I don't want to press equals prior because then it's going to square the whole thing, and I only want to square the velocity. Now, as I get ready to type that in, I end up with my correct answer. And I swore there was a better button for that. Oh well. All right. So if we look here at the next example, what is the kinetic energy of a ball that gets thrown, or a 1.2 kilogram ball, my mass, gets thrown in the air with a speed of 8 meters per second. That is my velocity. So 1/2 mv squared, 1 divided by 2 is 0.5. the mass, which is 1.2, and the velocity of 8. And when I type this in, so my calculator, 0.5 multiplied by 1.2 times 8 exponent button 2 equals 38.4. Okay. Looking at example number 3, I have a 3 kilogram book, that's my mass, resting on the top of a 1.8 meter shelf. Since it's resting on the shelf, that means it is not moving. That's the velocity is 0. So when I type 0 in for the velocity, I end up with 0 joules. This 1.8 meter shelf, that is a height. That is not used in this particular problem. If I wanted the GPE, I would use it, but it's not asking me for that. It's asking me for the kinetic energy. Okay, to find the kinetic energy of the coaster at different points. They're giving me a mass and they're giving me the velocity. I want to type into 1/2 mv squared. This one is done for you on this slide. And I have all the other solutions posted on the next one. But if I'm looking here, 0.5 times my mass, that's actually 1,600. And that is the right answer. I just had the wrong mass typed out. Okay, but if it's moving at different speeds, it's going to have a different amount of energy. And again, all those calculations where V is 25, when I type in 25 and square it, I end up with 500,000 joules. If it's moving 5 meters per second, it has 20,000. If it's 21 meters per second, it's 352,800. If it's moving at 17 meters per second, when I type that in and put it in my calculator, 231,200. Whenever it is moving at 25, it's the same as what it was at 0.1. Just keep in mind, if you are trying these out, please make sure you're getting the same answers. If not, please shoot me an email and I can try to help you out. Maybe you're squaring the wrong thing. Maybe you're pressing equals prior, but these are the correct solutions. Again, another just example of going through doing the calculations. I have 3,000 kilograms. If it's going 32 meters per second, again, 0.5 times the mass. And again, the only thing that's going to change is the velocity. And here's the different values for those different energies on this particular problem set. Okay, that's kinetic energy. Good luck on your assignments.